Hey friends, today we're going to learn about improper fractions. By the end of the lesson, you want to be able to write an improper fraction for a model and identify an improper fraction on a number line. So you want to get out your fraction notes and you're going to add this word, improper fraction. And an improper fraction is a fraction that has a numerator that is greater than the denominator. Add this definition and then you'll add some examples later on to your fraction notes. So, like I said, an improper fraction is a fraction where the numerator, or the top number, how many pieces you have, is greater than the denominator. The bottom number, which is how many parts are in one whole. So in an improper fraction, when you have more pieces than there are in one whole, you have an amount that's greater than one whole, similar to a mixed number. Improper fractions and mixed numbers go together. You can go from one to the other. For example, in this image down below, this represents 7/4. And we know that because there are 7 squares shaded, 1, 2, 3, 4, 5, 6, 7. And each whole, one whole square is split into 4 equal pieces. So that's our denominator. 7, how many pieces we have? 4, how many parts are in one whole? If you're thinking back to mixed numbers from last week, you might also be saying we could write this as 1 and 3/4. And you'd be absolutely correct. These equal each other. 7/4 is the same as 1 and 3/4. So here's just another example. When you have a fraction like 2/3, where the numerator is smaller than the denominator, this means that you have less than one whole. You have less pieces than there would be in one whole. When the numerator and denominator are the same, like in 3/3, that equals one whole. You have the same amount of pieces as there are in one whole. In an improper fraction, 4/3, what you have is more than one whole. You have one whole and some extras because the number of pieces you have is more than the number of pieces you would need in one whole. So, an example, Mr. Williams has some strips of wire. The wire is measured in 1/3 meter units. Let's count the parts to see how much wire he has. 1/3, 2/3, 3/3. So this would be 1 whole meter. But then he has another 1/3 piece. So we could say he has 4/3, 4 1/3 pieces, more than 1 whole meter. 1/3 plus 1/3 plus 1/3 plus 1/3. The denominators are the same, so you just have to add those numerators. 1 plus 1 plus 1 plus 1 equals 4/3. This is an improper fraction. Oh, this is going to be written in a fun way. Improper fraction, meaning that it's more than 1. In this case, Mr. Williams has more than 1 whole meter. In fact, he has 4/3 of a meter. 4/3 is the same as 1 and 1/3. He has 1 and 1/3 meters of wire. Because we can see here, he's got 3, that highlighter didn't work at all. He's got 3/3, which is equal to 1 whole, and then he has 1 extra. 1 whole plus 1/3 more. 4/3 equals 1 and 1/3. All right, let's look again. Let's use this model to see how much wire he has now, a different way to look at it. So here he has 3/3 of a meter of wire, 3 out of 3, which means 1 whole. Here he has 2 out of 3, or 2/3 of a meter of wire. If you add these together, since they have the same denominator, 3 plus 2 equals 5, and the denominator stays the same. So he has 5/3 of a meter of wire. Based on the improper fraction and the image, we can tell that that's more than 1 whole. He has 1 whole meter right here, plus 2/3 extra, which means 5/3 is the same as 1 and 2/3. So how much wire does he have now? You could say he has 5/3 meters, or you could say he has 1 and 2/3 meters. Now, if you're wondering, well, why are we calling them improper fractions? Stop and ask yourself, what does improper mean? If someone says, oh, you're being so improper right now. Well, improper usually means you're being wrong, or you're being inappropriate, or you're not acting right. And when we look at an improper fraction like 5/3, are we used to seeing the numerator bigger than the denominator? No, it just seems wrong. It seems improper. That's how I'd like to remember it. But all improper fractions are fractions where the numerator is greater than the denominator, and it equals more than 1. All right, let's use this number line to see what we just did. In yellow, I've highlighted our whole numbers. So 0 to 1, between these two is 1 whole. 0 to 1, 1 whole. From 1 to 2, that's another whole. If we're looking at fractions, when we start at 0 and we look to 1, so our space between 1 whole, we can see that it's broken into 1, 2, 3 parts between one whole number and the next. That means our denominator is going to be 0 because 1 whole is split into 3 equal parts. 0 then would be 0/3. 1 jump, 1/3. Another jump, 2/3. Another jump would be 3/3, which we know is the same as 1 whole. Now, just because it goes all the way to 1 doesn't mean we can't keep going. We actually have to go past. So after 1 whole or 3/3, our next jump, we could say 4/3, improper fraction showing that we have more than 1, or 1 and 1/3, a mixed number showing we have more than 1. Our next jump, 5/3, or 1 and 2/3. Our next jump, 6/3, or would have been 1 and 3/3, but because a fraction with the same numerator and denominator equals 1 whole, 1 and 3/3 would actually just be 2, because you have 2 wholes right here. On top, you can see our mixed numbers, which are with a whole number and a fractional piece. And on the bottom, you can see our improper fractions, where the numerator is greater than the denominator. If you look at this, 3/3 plus 3/3, 1 plus 3/3, we end with 6/3. All right. Now, to find the improper fraction, if you're looking at a model, you need to ask yourself a few things. Number 1, what is each whole divided into? So in this picture, we have 2 holes, but they're not all filled out. This is the only hole that is completely filled out. So what is each whole divided into? How many parts? Well, 1, 2, 3, 4. Since 1 whole is divided into 4 parts, that means our denominator is going to be 4. Okay. Next question, how many total pieces are shaded? Not just in the 1 whole, but in all. Well, we have 1, 2, 3, 4, 5. So we have 5 pieces shaded, and 1 whole is broken into 4 parts. So you can say we have 5/4. That is our improper fraction. We have 5 pieces shaded, but 1 whole is broken into 4 equal parts. Okay? So once again, we can say we have 5/4. Or if you want to look at it another way, you have 4/4 plus 1/4 equals 5/4. But because we can write it as a mixed number, you can also say you have 1 and 1/4. 1 whole plus 1/4 more. Mixed numbers, improper fractions. You can go back and forth. 5/4 is the same as 1 and 1/4. What they have in common, mixed numbers and improper fractions, they are all greater than 1. Mixed numbers, improper fractions, greater than 1. Let's look here. In this image, it asks how many halves are there in 2 1/2. Remember that 1 whole would equal 2 halves. So how many halves are there? Well, 1, 2, 3, 4, 5. We have 5 pieces or 5 halves. But for our denominator, we have to ask how many parts are in 1 whole. Well, here's 1 whole. How many parts are in it? 1, 2. So the denominator of our improper fraction will be 2. This image represents 5 seconds or 5 halves. We have 5 pieces, 1, 2, 3, 4, 5, but one whole circle is broken into 2 parts. That's our denominator, 5 seconds. Another way you could write that as a mixed number, well, we have 2 whole things, 2 whole circles, plus 1 half more. So 5 seconds is the same as 2 1/2. Look at this image, write as an improper fraction and a mixed number. Let's start with an improper fraction. All right, so we have our fraction. We know with an improper fraction, we have a numerator that's bigger than the denominator. And our numerator is how many parts we have shaded. So let's look. 1, 2, 3, 4, 5, 6, 7. Our numerator is 7. Our denominator tells us how many parts 1 whole is broken into. This square is 1 whole, and it's broken into 1, 2, 3, 4 parts. So our denominator is 4. This model right here is the improper fraction 7/4. But how else could we write that as a mixed number? Well, we have 1 whole square filled in, 1 whole, and then we have 1, 2, 3 extra pieces, and our denominator will remain 4, because 1 whole thing is broken into 4 equal parts. 1, 2, 3, 4. 7/4 or 1 3/4. If we look at this number line, what is the missing improper fraction? Well, let's take a look. We can see, let's find our whole numbers first. We have 0, and here's 1. Because our number line goes past 1 and we're working with fractions, we know we're going to have some mixed numbers and some improper fractions because those two things are greater than 1. If we're looking down here, we see that this point where we're missing our improper fraction is 1 3/4. So what improper fraction is the same as 1 3/4? Well, if you look at the number line below, 1 is 4/4. You just keep on going. 5/4, 6/4. This would be 7/4. And if you think about our mixed number over here and how you could visualize that, well, if our denominator is 4, and that means 1 whole would be 4/4. 1, 2, 3, 4. And then if we have 3/4 extra, that means we have another 3 out of 4 pieces. And if you count those up, 1, 2, 3, 4, 5, 6, 7, There's our numerator. And our denominator is 4 because 1 whole is broken into 4 equal pieces. 1 3/4, 7/4. Place these improper fractions on the number line. Another practice. Remember, if we have improper fractions and mixed numbers, those are the same because they are both greater than 1. Improper fractions and mixed numbers means you have more than one of something. All right, let's look at this number line. And once again, I like to find my whole numbers. So here's 0, 1, 2, 3. All right, let's start moving these. 2 seconds. What do you know about 2 seconds? Well, since the numerator and denominator are the same, that is equal to 1. So I'm going to take my 2 seconds and drag it down below 1, because those are the same. What about 3 seconds? Well, if I'm looking at my improper fractions on the bottom, this could be 0 seconds or 0 halves, 1 second, 2 seconds. This would be 3 seconds. And honestly, you just keep on going. Next. 4 seconds. Keep going. What would 2.5 be? What was the improper fraction version of 2.5 looking at this number line? Or 2 and 1 second? Well, that would be 5 seconds. And finally, 6 seconds at the end. Improper fractions and mixed numbers. You can go back and forth between them, and they're similar because they represent an amount more than 1. All right? The last thing we need to look at is the fact that you can sometimes simplify improper fractions. When we can, we need to simplify improper fractions, and the process is the same as simplifying proper fractions. Do you remember those steps? Well, in this improper fraction over here, we have 14 tenths. Now, in order to simplify 14 tenths, we need to find the factors of 14, the factors of the numerator, and the factors of the denominator. List the factors of each number, numerator and denominator. Well, for 14, every number has at least 2 factors, 1 and the number itself. All right, what about 2? Does 2 work? 2, 4, 6, 8, 10, 12, 14. Okay, 2 times 7 equals 14. All right, what about 3? 3, 6, 9, 12, 15. Nope, that doesn't work. 4. 4, 8, 12, 16. Nope. I know 5 won't work because 14 doesn't end in 0 or 5. Let's try 6. 6, 12, 18. Nope. Next number to try would be 7, but since we already have that, we know we're done. The factors of 10. Every number has at least 2 factors, 1 and the number itself. Okay, let's try 2. 2, 4, 6, 8, 10. 2 times 5. Does 3 work? 3, 6, 9, 12. Nope. What about 4? 4, 8, 12. Nope. The next number to check would be 5, but we already have it. So we're done. Now that we found the factors of each number, we have to circle the greatest common factor of the 2 numbers. What's the biggest factor that they both have in common? In this instance, the biggest factor they have in common is 2. Once you find the greatest common factor, you need to divide the numerator and the denominator by that greatest common factor. The reason you're finding those factors is because you want to divide the numerator and denominator by the biggest same number possible. In this case, we discovered that our greatest common factor was 2. So in order to simplify, I'm going to divide my numerator divided by 2 and my denominator divided by 2. And we'll see what we get. All right, 14 divided by 2. How many groups of 2 can I make with 14? 2, 4, 6, 8, 10, 12, 14. I can make 7 groups. And the bottom, 10 divided by 2. Hopefully this one was mental math. That is 5. So not only did we have our improper fraction of 14 tenths, but we were able to simplify into 7/5. Let's try one more of those. All right, improper fraction is 15/6. We need to simplify that. So step 1, list the factors of each number. Our factors of 15, we'll do a factor rainbow for this one. Every number has at least 2 factors, 1 and the number itself. All right, let's try 2. Will 2 work? 2, 4, 6, 8, 10, 12, 14, 16. Nope. What about 3? 3, 6, 9, 12, 15. 3 times 5. All right, what about 4? 4, 8, 12, 16. Nope. The next number to check would be 5, but we already have it, so we're done. Here are our factors of 15. Now what about our factors of 6? Well, every number has at least 2 factors, 1 and the number itself. Let's try 2. Well, I know that 2 times 3 is 6. And because our numbers met in the middle, we are done. Now, let's circle the greatest common factor between the two. What's the greatest common factor of 15 and 6? That would be 3. And now that I know that, I can divide the numerator and denominator both by 3 to get my simplest form fraction, my fraction that is as small as possible. I know that 15 divided by 3, how many groups of 3 can I make with 15? 3, 6, 9, 12, 15. Make 5. And 6 divided by 3. How many groups of 3 can I make with 6? 2. So there is my simplified fraction. 15/6 in simplest form is 5 seconds. All right, your turn to try.